She is a professor of psychiatry at the university, no, in the Department of Psychiatry in the University of California, San Diego. She obtained her PhD last year, I suppose not, in clinical neuropsychology, which makes us very similar, and in cognitive psychology. She did then her postdoc in San Diego, not in the Center for Research on Language. And we know Tamar very well. Her early studies on the TOT phenomenon, tip of the tongue, word retrieval, and all the things they were very influential even in my career. And later on, she started studying also Alzheimer's disease, aging, especially one of the first papers even in our field on multilinguals and aging, if it protects or not, if there's an effect. But I remember the first work was actually contrary, but then proficiency matters and the number of languages and all these things. But in more recent years, Tamar has created the MINT, the MINT, okay, the multilingual naming test, and she has spent a considerable time in studying language switching, especially language control. And today she will give us a nice presentation on language control and language switching, I suppose. Yes. Okay. Tamar, we're really happy to have you here.
It's really great.
And we also hope that you're enjoying your time in Tromsø.
Very much so. Thank you. Thanks for that introduction, Shumin. And it's great to finally get to be here. I've wanted to come visit for a really long time. So bilingualism and language control. And today I'm going to talk a lot about a very intuitive mechanism, which is also as hotly debated as it is frequently proposed, which is, do bilinguals inhibit the language that they don't mean to speak when they're speaking, when they're switching languages, and how do they do that? So when I was a kid, I had this idea that a bilingual is like a chameleon, that whatever environment you're in, nobody would know that you have this other hat that you wear, this other language that you speak, another almost identity, if you want. And if I had something I could do in one language that I couldn't do in the other, I always felt really bad about that and felt like it was, somehow inadequate. But as I started studying bilingualism, I realized pretty quickly on that most bilinguals have a more dominant language. In some cases, it'll be one language is dominant for one thing and the other language is dominant for the other, but it's really rare. Chameleons are rare. They're professional translators with extremely large working memories and all of this kind of thing. And I also learned that it's not a bad thing that bilinguals are like that, because in terms of cognitive processing, some of the most interesting questions we can ask are actually questions that will be asked of people who have one clearly dominant language. And then the question becomes, well, how do they speak the non-dominant language? And today I'm going to spend a lot of time trying to explain why we propose that inhibition is a part and parcel of any theory of bilingual language processing, especially bilingual language production. But as it turns out today, some tasks that we thought of as being purely comprehension-based are also showing signals of extra control on the dominant language to let the non-dominant language have an equal chance of coming out. And so hence the title, Inhibition, Is It Really Just for Speaking? And so just a quick sense of the talk outline. The first two parts are things that many people may have heard before. And so I'm going to go pretty quickly, but there's a lot of repetition of ideas, repetition of data patterns. And so I'll try to walk you through that quickly and then get towards the end where we've started using eye movements to help us understand what's going on when bilinguals are switching between languages in connected speech. And we elicit that via reading aloud of short stories or short paragraphs. And we're also going to touch on this question that is of broad interest in this crowd. Is the inhibition that I'm talking about domain general? I don't have an answer to that question. And so that is an open question that we will consider. And reversed language dominance is this, what we're going to call this, I think, the most compelling evidence for inhibition as a cognitive mechanism in bilinguals. And we have older participants showing this reversal of dominance, which we'll talk about a lot, in some tasks, but not in others, which opens up this question, well, then if it is domain general, how is it that older bilinguals can reverse dominance sometimes, which presumably requires some form of inhibition to be intact? And also along the way, very, very briefly, but I'm happy to talk more about it if people have questions, who is bilingual? How do we measure that? And what's wrong with just asking people, are you bilingual? And how bilingual are you? Okay, so starting with the picture naming task and evidence for inhibition in picture naming response times. So we're going to start with a quick exercise. If you see the American flag, name a picture in English. If you see this is the Mexican flag, if you know Spanish, feel free to use that. If not, use any other language that is as accessible to you as easy as possible to name the picture. Okay, you ready? Okay. Compare that to this condition. You don't have to do it, but I can tell you right now, you'd be much faster, less hesitation. The delay and trouble people experience on switch trials, especially when it's presented like this, which is a little bit of a departure from how we actually do it. In the experiment, you would only have one picture on the screen at a time, but you can feel it. You can feel the switch cost. It's dramatic, and you can detect switch costs in a single subject if you have just 30 trials or so. So when we look at trials where, can you see this arrow? Yeah. So this was in English and now it's switching to the other language. That's a switch trial. Similarly, this is a switch trial. So how long it takes you to name this picture is affected by the fact that this is a previous trial was in a different language. By contrast, these are stay trials, meaning the previous trial was in the same language. And when we compare switch minus stay, that is a switch cost. And when we compare mixed testing blocks to a single language testing block, we call that a mixing cost. And the field is like almost obsessed with these two measures of language control. And it's neat. They tidy things up and they have things very nicely experimentally controlled. But so obsessed with these two costs as separate entities, which is really not real, right? Because both have stay trials in them, that I think we missed the implications of full reversal within the mixed language block. Initially, when it came out, certainly that was true. And then even to today, I will see fully reversed dominance sometimes in a mixed block and a whole paper and no mention of the fact, even though that's really the most striking evidence, I think, something signature of inhibition. So when bilinguals name pictures in a single language block, the dominant language, you'll see in all the slides, tends to be darker or bolded, and the non-dominant language both get stronger with repetition. This is an experiment where we just, in order to illustrate the effects of repetition, divided the blocks into quartiles and just sort of see how language dominance shrinks over time. But if you look at the mixed block, and I'm going to show you now the stay trials. So this is your mixing cost, much slower. And you can see at the beginning, the dominant language is faster than the non-dominant language. But over time, the dominant language gets slower with repetition in this study with hundreds of Spanish-English bilinguals, to the point where by the end of the mixed block, dominance was completely reversed. And so this pattern, especially of unfolding and increasing kind of facilitation for the non-dominant language with repetition, which is what you would expect. You do things repeatedly, you get faster, right? But the dominant language is having the opposite effect. And this is freaky and wild. Like, I can't emphasize this more. When I first saw this pattern, it was a paper of Albert Costa's. I was reviewing and I wrote to the editor and I said, I think they switched their conditions by mistake. Can you just check with the authors and make sure that this isn't an error? If we think about trying to understand this, we can try to think about what would be comparable. Is there any comparable phenomenon in the world, right? And so you can think, well, maybe if you could suddenly, if you're right-handed, write better with your left hand, maybe that would be comparable. Even being equally proficient in your two languages when you have one clearly dominant language is unexpected. It's happening. Oops, sorry, that's.
Huh?
How did I do that?
I don't know.
I'm sorry, I'm sure it's my fault.
The Teams window is just the participant. So,
And you fixed it. Thank you. Okay, let's think about some more things that might be analogous. Preferring to sing alto if you're a soprano or vice versa. Turning a night owl into a morning person. Preferring backhand over forehand in tennis. It might, running slower than you walk, right? Reverse dominance, I think, is a very powerful signature of inhibition of the dominant language. We can also think about things that it probably is not like. And so if you're trying to handstand, for example, you're probably not doing that by inhibiting standing on your feet, right? There you have to activate to stand on your hands. Now, of course, inhibition couldn't possibly be the only thing that you do in order to speak in a non-dominant language. If you inhibit your dominant language and don't activate the non-dominant one, nothing will come out when you try to speak, right? So we need more than one mechanism of control. But I just wanted to point out that this unfolding of reversal is a really strong evidence for inhibition. This shows a recent replication. This paper just came out, showing repetition on the x-axis. So each picture was presented 8 times. And this is separated out by whether the trials are stay or switch. It's a little easier to see what's happening if you collapse across that and just make 2 lines. The dominant language doesn't benefit from repetition, whereas the non-dominant language gets faster with repetition. And this is another form that this kind of reversal over time can be found now in the literature. We have another paper in press that Kalinka Timmer and colleagues just published with Polish-English bilinguals. So these are Spanish-English bilinguals at UCSD. These are Polish-English bilinguals, very different type of bilingual. Again, each picture being named 8 times. And you can see that she has trial number as her preferred way of graphing it. And these are 2 different contexts. One where they're switching back and forth between languages, but the fillers surrounding those little switching islands, I'd like to call them, are mostly in the dominant language, where here they're in the non-dominant language. And you can see there's hundreds of trials at the beginning. The dominant language is faster, and then by the end, the non-dominant language is faster. Dominance reverses. Here's the paper of Albert Costa's, one of, gosh, I don't know, 5 experiments in that paper, I think, again, with a small set of items repeating over and over, and reverse dominance in the mixed block. Here's an example with German-Dutch bilinguals, an example with Dutch-English bilinguals, German-English bilinguals, Chinese-English bilinguals. This is one of those papers where they don't talk about it, but I'm pretty sure that this would be significant reversal if they were to analyze it that way. And these are the single language blocks, and you see the crossover. So normal dominance in the single language blocks and reversed in the mixed block with Finnish-English bilinguals. This provides striking evidence for the inhibitory control model, which states inhibition in multiple processing levels. So to speak a non-dominant language, bilinguals inhibit the dominant language at the whole language level, which could be an effortful and controlled process. There's also direct competition between translation equivalent lexical representations, and this may be a more reactive and automatic process, but also involving a form of inhibitory control. One of the things I've been asking in my research is at what processing levels do we have inhibition? Could you also, so you have it at the whole language level, you have it at the lexical level, could you also have it at the level of accent? And we have some speech errors that suggest that that's possible. And so we'll visit some of those data. This is something that is in need of replication. Measuring accent is something that's not easy to do. I just wanted to point out that the inhibitory control model has been cited almost 2,000 times, David Green's paper and your paper, Zhubin, with David. Same thing. Very commonly proposed, But when you talk about inhibition outside of certain circles, people get very fussy and upset. Another hypothesis that focuses on inhibition and is hotly debated is the inhibitory deficit hypothesis, which basically states that inhibition is impaired in aging, which impairs the ability to control what enters working memory, inhibition of no longer needed information, or processes that reduce the probability of incorrect but relevant responses. And we decided, okay, let's see, is it the same inhibition? If it is, we should see some form of evidence that older bilinguals are not as able to switch languages as young bilinguals, or don't reverse dominance in the same way. And Elena Stasenko, one of my PhD students, she's now a colleague in radiology at UCSD, found exactly that. In one of our mixed language blocks, young bilinguals reversed language dominance, but older bilinguals did not. And older bilinguals also more often failed to switch when they were cued to switch, so they produced more errors in the task as well. And now I'm going to show you, we just replicated this as a tiny piece of that Garcia and Gollan paper that I was telling you about in a study where we had 3 sets of 10 pictures, so 30 pictures in all, counterbalanced between subjects across condition. Bilinguals named pictures where with what we're calling no bias, meaning each language was used equally often. And then similar to Kalinka-Timmer's paper, we had a condition where the dominant language was used much more often than the non-dominant language, and the reverse, meaning what happens when you rarely switch, and does it matter which language is being used most of the time throughout the testing block? And how do older bilinguals do with this? Because one of the questions that is a little bit unclear in the field, it depends on if you read my papers or there are a few other people studying aging and language switching, like Angela de Bruin, and sometimes she reports increased switching costs in older bilinguals, and we sort of see that, but if you control for response slowing in aging, it's no longer significant. And so we said, well, okay, what happens if you make it really hard? They're hardly ever switching. Okay, they're mostly just using one language and then rarely have to switch out. Do we then see older bilinguals have a harder time? And we thought maybe we would. And so this just shows the no bias block. These are the data that I showed you before, separated out by the 8 repetitions. So this is just collapsing across that. And you can see the stronger language is slower in this mixed language block. And then switch costs. And these are the older bilinguals. They are slower. They don't reverse dominance. The lines are just like right on top of each other. And so replicating Elena's paper. Now here, to get an idea of what the context manipulations are like in this dominant bias context, most of the time you're naming pictures in English. Every once in a while you switch into Spanish, stay in Spanish, and then switch back to English and keep going, mostly in English. And then the same thing in the non-dominant language. If Spanish is your non-dominant language, you'll be mostly naming pictures in Spanish and then switching out, staying out, and then switching back. And this was sort of what we were thinking might give us that aging deficit in switching. And here are the young bilinguals in the dominant bias condition, and here they're staying in the dominant language. This is most of the trials. And then switching out to the non-dominant language, staying out in the non-dominant language, and then switching back. And you see the data look, so dominance is not reversed, right? They're producing the dominant language faster. It's also being repeated more in this block, and so that could be part of what's going on there. But the switch costs are exactly the same. So switching out wasn't harder for them, and switching back also wasn't free. We thought switching back, maybe, you're in that mode where that language is being used most of the time. Maybe switching back would be cost-free. Not in this paradigm. Okay, what about the older participants? They're slower, and they're faster in the language that's being used most of the time, only on stay trials. This is the switch out cost. This is the switch back cost. And switching back was what was hard for the older bilinguals. Very unusual, not what we expected. And this is only showing you the dominant bias condition. Now I'm going to show you all three: the no bias, dominant bias in the middle, non-dominant bias in the red. And the lines are just flipped because this is the biased language now. The non-dominant language is being used most of the time. It's fastest. Switching back was harder for the older bilinguals in both of these conditions, not switching out. This is, like I said, not what we expected. And so we hypothesized another kind of proactive control deficit where in order to switch out, you have to hold on to that language that is biased in the block, even while you switch out of it. And that is a kind of proactive control. It's an kind of activation, keeping it on while you temporarily switch out in order to then switch back easily. And older bilinguals seem unable to do that. So we did get a form of switching deficit, but not the one that we expected this paper. So this paper is out in Cognition. This was part of Dalia Garcia's dissertation work. Okay, so we have multiple mechanisms of bilingual control. To control their languages, bilinguals globally inhibit the non-target language and globally activate the selected language, and then respond reactively to cues to switch. Reactive control seems to be intact in older bilinguals. They switched out of a selected language really well, even though they were using it almost 90% of the time, and even though those switches were cued and forced and rare. They happened on 6% of trials in those blocks. Whole language control, though, seems to decline in aging. Older bilinguals did not reverse dominance. We have that in 2 studies now. And this is our interpretation, that they couldn't proactively hold on to activation of a selected language while temporarily switching out of it. And this resulted in very big switching back costs. We also see really powerful context effects. And when the non-dominant language is selected, it may behave like the dominant language. This is Kalinka Timmer's characterization. I think it's really cute and easy to remember. She has a similar patterns in her paper. Okay, let's talk for just a minute about who is bilingual and how do we measure that. We have turned this into a fast and efficient process out of need in clinical settings where testing someone, doing a cognitive evaluation in a language that's not their dominant language potentially leads to false positive diagnoses of various forms of cognitive impairment or cognitive decline. And something that has to be avoided, but time is always short in clinical settings. And so we developed the multilingual naming test and the sprinting version. And then if you want, ask me later why we don't rely on self-report. One of the reasons I'll tell you now is that the older participants tend to be very conservative in their ratings. They will tell you that they're not very good they're not very bilingual, they're not very good in proficiency in either of their languages, and then name many more pictures than the young bilinguals who say that they're perfect bilinguals. And we've just been burned too many times. So we use an objective measure. This is our naming test. We tell people they have 3 minutes to name as many pictures as they can, starting at the top and going left to right. And we don't actually stop them. So a college-educated monolingual English speaker will finish this entire thing and name most of the pictures correctly in about 2 minutes. A bilingual will take a little bit longer. But it's pretty quick, and so this is our operational definition of language dominance. Whichever language gets a higher naming score, and the non-dominant language is the other one. We sometimes will divide the non-dominant score by the dominant score to get a measure of relative balance, with 0 being profoundly monolingual and 1 being a perfect bilingual who names the same number of pictures in both languages. Scores on this test correlate at 0.8. I think Anne Neveu is here. She did this research project with us, and we found that this is pretty good with our gold standard measure of proficiency, which is a much more time-consuming oral proficiency interview and takes 10 minutes roughly to administer in each language, and then another 10 or 20 minutes to score because you have to score, listen to the whole interview and score. We did this with 80 participants and then correlated with various objective measures of proficiency and found that our naming test performed pretty well. If you want this test, we have the test and demonstration video, everything you need at this OSF link. And if you just search Mint Sprint 2.0, you'll find this and you can use it and adapt it for your purposes. Okay, so now we're going to switch gears a little bit, and I'm going to talk about how we use reading aloud to elicit connected speech and the evidence that we have for inhibition in that task. So normally bilinguals switch languages when they want to. Sometimes they switch frequently, sometimes like I'm right now, not switching languages at all, and very rarely switch by mistake. So when I first started trying to study language intrusion errors, I thought it was an impossible task. And I gave a talk and said, we can't get bilinguals to mess up. And Keith Rayner raised his hand and he said, many years ago, Paul Kohlers ran this study where he had bilinguals reading aloud and they produced lots of language intrusion errors. And I looked at Keith and I said, no way. I don't believe you. We argued a bit. We walked into his office and he opens this long file cabinet drawer and pulls out a paper from 1966 and hands it to me and he says, look. And I flipped through it and find this one paragraph with French and English mixed randomly and crazily. And I said, oh, you forgot to mention this one little detail, Keith. And found a French, Spanish, English trilingual undergraduate student who helped me create paragraphs for Spanish English bilinguals just to see if we could replicate this phenomenon. And I and she and two other lab assistants who are native Spanish English bilinguals, we all sat around the table reading aloud these paragraphs that we had written to each other. And as we're doing that, we started producing these errors. And we're like, okay, this is going to work. And so that's what we've been doing for a number of years. So this is a hybrid task. It is speech elicited through reading, but you get connected speech. You have really nice control over what people say, and it is a really handy task. We've been saying that this task mostly measures planning of and control over production of speech, but my thinking on this since we've gotten this eye tracker is starting to change a little bit, and we'll see what you guys think. But I want to show you an example. So this paragraph looks totally fine. This is what participants will see, something that looks like this. But really, this has a handful of switch words in it. So the first thing we did was do the crazy switching, and then we went to this more measured sort of less frequent switching, less crazy, still crazy in some ways. Bilinguals don't switch on, so the words that are bolded in red are the function word switches, and those are the ones that elicit the most intrusion errors. And I'm going to show you an example of that. Now you're going to see a person say that this instead of que, which is the translation equivalent, and just carry on as if nothing happened. And this is one of our older participants. This is a young old person, 69 years old, with very high naming scores in both languages. Here, he produces a within language error. He inserts the word would where it's not there. Here he says may instead of Mary. Then you'll see this little dot showing where his eyes are looking while he's reading aloud, and he regresses back and then fixes it and carries on. When he gets here, just keeps going, doesn't even notice. And then here we have another within language error saying would instead of could. So let's have a look at that.
Mary grew up watching her favorite game show with her father. Every Sunday in the mañana, the two of them would have breakfast together mientras they would watch the show. He tried to guess the respuestas to all the questions. After años of watching, they both became pretty good at guessing. It had been some time since Mary had heard from su father. Last week, he phoned her to tell her that the show was coming to Seattle, where ella lived. Mary siempre wanted to be a concursante, and so she signed up right away. To prepare, Mary went to her father's casa the following domingo so they would revive their tradition of eating desayuno and watching el show together. She was so feliz to be there, pero sad it had been so long since she had spent time together with her father.
Okay, now I'm going to show you a different kind of error that we get is the one that led me to wonder if maybe inhibition could be applied just at the phonological level. So this bilingual, she's young, she's 21 years old, again, pretty balanced. She's Spanish dominant. She scores 10 points higher in Spanish than in English on that naming test. When she gets here, she starts to say triplets. It sounds like she's starting to say it in Spanish, but it ends up coming out just Spanish with English with a Spanish accent. But then here and here, she produces it as she normally would, and that's kind of how we know that this is an error, not just her accent. So let's have.
Many years went by, and los triplets came to be young teens. From time to time, they would hear gossip sobre their parents here and there, or at school. The gossip was heard more than anything else among the kids que were order at school, who surely had heard something from their parents or grandparents. But para avoid problems, the triplets pretended not to hear. Nevertheless, they became fed up with what was said. One day, their curiosity got the best of them, and they told su mother about their schoolmates' gossip. That same evening, when she got home from the store, their mother gathered her children to explain to them certain things que she had promised them some time ago. It was time for the triplets to know more.
So clearly, she doesn't normally say triplets. That just came out that way. When I told Matt Goldrick about this phenomenon, he was kind of skeptical. And then I sent him some examples, and he made this video for me, sound file for me, where you can hear the two ways she says triplets, one right after the other.
Triplets, 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 triplets.
It's great. Like, okay, that's an accent error, right? And so the first study that we did of reading aloud, we included accent errors as one of our measures.
Triplets, triplets.
Whoops. Okay. This shows you all the language control errors. This is producing a full intrusion error, and so saying que instead of that, or vice versa. This is what the within language errors look like. And this is when the target language is the dominant language, English for most of these participants. So within language errors, like saying could instead of would, happen much more often in the language that's not dominant. All the language control errors, including production of a full intrusion, starting to produce an intrusion and then stopping yourself in the middle of the word and correcting it, or those accent errors, it's the opposite. It's the dominant language. Switching to the dominant language is what's hard. It's what gives you the most errors in this task. This phenomenon of reversed dominance in the intrusion errors is so robust. We've replicated this over and over. And this is what led us to say maybe, okay, when you want to speak Spanish, if your English is normally stronger than your Spanish, you will inhibit at a whole language level. And this makes it possible to select a lexical representation in your non-dominant language. But maybe there's also a control process operating directly on the planning of sounds, and that's what gets you those accent errors. This is just a list of replications. So we've replicated this with Chinese English bilinguals 3 times, showing various things like cognates elicit more intrusions. If you're bilingual and old, you produce more intrusions. If you have Alzheimer's disease, you produce even more intrusions in this task. With eye movements, we showed people do intrude less if they gaze longer, but this doesn't interact with part of speech, so that can't tell you why those function words are more vulnerable to errors. And regressing will help you self-correct content word switches, but not function word switches, is what we reported in this first paper with eye movements. But I'll show you some data on that suggests something a little bit different now with the Spanish-English bilinguals. Chu Lee recently showed that even if you show the paragraphs word by word very quickly, you get intrusion errors in this task, especially for the dominant language. We get them with Hebrew English bilinguals and Chinese English bilinguals, which really suggests it's not about misreading words or something like that. Color cues will reduce the rate of intrusions. The older participants in this task show reverse dominance, which is that question that I was saying, if inhibition is impaired, and we saw evidence of impaired language control in older bilinguals in a different task, why are they able to inhibit in this task? Function word switches are easier if they're supported by context, and with this task, we do get switching back for free in one of our studies. Jesse Quinn showed a couple of years ago, you will get fewer intrusions if you have people read a random salad of words as if it's a paragraph. And so there are various things that can move things around in terms of how many intrusions you get, but even in a random word salad, language dominance is still reversed. And finally, we used a set of paragraphs with dense language switches to show that the dominant language is more vulnerable to intrusions, even on non-switch words in these paragraphs. This was kind of hard to do, but this suggests that it really is reverse dominance, not just a switch cost. This is something we're still trying to figure out. Okay, so facts so far. In picture naming, language dominance reverses with repetition in young bilinguals, but not in older bilinguals. In reading aloud, language dominance reverses in intrusion errors, even in older bilinguals, even in people with Alzheimer's disease. So maybe this form of inhibition is language specific, automatic, and driven by syntax. In this task, contextually supported switches, so if the language continues on in the switched to languages, you get fewer intrusion errors. You don't get errors on switching back. So if the paragraph is mostly written in English, switching back to English doesn't seem to elicit intrusion errors. And then these types of switches where there's contextual support for the switched to language also don't elicit intrusion errors. All of this seems to suggest when speakers are bilingual and intend to engage in bilingual speech, they will always nominate one language as the morphosyntactic frame of clauses. Selecting a matrix language for the frame must mean inhibiting the other participating languages, at least for this role, possibly along the lines of Green 1998. So this is Carol Myers-Scotton proposing something that is very much in line with how we think about what's happening in this task. And if you're interested in that and in syntactic control, this is a short research report where we talk about all of these ideas and why we think inhibition is the mechanism that's implied. Okay, so the last part of the talk, these are brand new data, and I have Jesse Quinn joined on Teams to answer questions about this as we go. And I will need help with that, and let's see her, but we will get to that later. Okay, so in the last couple of years, we started using eye tracking to try and understand better what happens in this task. This picture shows my colleague Chu Lee setting up an eye tracker and getting ready to track Jesse Quinn's eyes. And then that's me with the ready to have my right eyes tracked. This image shows the portable tracker. Both trackers will use an infrared light to track eye movements and gaze duration. It shines this near infrared light to illuminate the eye and reflects off of it. And the video, very fast video, captures these images and then uses sophisticated algorithms to analyze the distance from the pupil to the corneal reflection to determine where the person is looking, even when their head is moving. This tracker defaults to 500 Hertz, which means it captures an image every 2 milliseconds. Shows it from the side, and now I'm going to show you a video that shows how it works in real time while Myra is reading aloud. So this computer on the left, normally the participant would be placed in a position where they can't see this computer. This is called the host PC, and it's receiving and processing images from the fast camera and computing gaze location as screen pixel coordinates and parsing the data and storing it. You'll see a moving dot that shows where she's looking while she's reading. And then the host PC also shows the experimenter how well the eyes are calibrated. Usually we just track the dominant eye. This video I like, it's cool. It shows both eyes being tracked, and she's reading one of our practice paragraphs.
Mr. Schwartz, the panadero on 6th Street, was well known for having el best bread in town. Lines of people would form cada morning as the hot bread was coming fresh out of the oven. Mr. Schwartz loved baking and he didn't mind waking up temprano to do su job. In fact, he looked forward to seeing his regular clients every mañana and talking with them. Everyone knew que they were always bienvenidos there and that the bread would always be waiting for them.
Okay. So what we perceived when we're reading is not the movement of the eyes, right? We perceive the movement of attention. We have this feeling that your eyes are moving smoothly from left to right if you're reading in English, from right to left if you're reading in Hebrew. But really what's happening is that the eyes are making rapid forward and backward saccades and fixations. Saccades are very small, high velocity jumps that our eyes make. And readers normally will make 3 to 4 saccades per second. And these are separated by moments where the eyes remain still, and these are called fixations. And we can use eye tracking as a window into the cognitive processing that is related to ease or difficulty of comprehending a task. So gaze duration, how long you look at a word, combining multiple fixations in some cases, is supposed to be one of the earlier measures, and it gives you an idea of how quickly you can access a lexical representation. Sometimes people will skip over a word, like a function word like the or his, and this is a sign of processing in the paraphobia that is so efficient that you plan a saccade that skips the word. And then you'll have things like regressions, where a person moves back to a word that they had already passed. And this is something that can happen to help integrating words into context or missing things that were missed to try to consolidate everything all together. And so skipping and gaze duration are considered early measures of access, whereas regressions and total reading times, which will include the fixations that happen during the regression, is more of a later stage measure. Okay, so now we're going to listen to one more example from Jesse's study. Oh.
Many dancers dream of becoming good enough to join the Royal Ballet, one of the best companies in the world. Alexa worked hard all her vida, sacrificing everything for this dream. When she was only 16, the company was holding auditions in La City of London, just a couple of meses after her birthday. Although she was just a young mujer, she decided she would try to audition. She was nervous porque the other dancers were surrounded by teams of people supporting them. She thought about all the advice the teacher at the ballet school had given her, pero could not help but anxiously watch the other dancers audition. She took a last sip of agua and then marched proudly onto the stage and stood in position. As soon as she heard the music play, she began to dance like she never had before. With each leap and paso, she flew higher in the air, and E found she could jump even higher on the next step. She found her number in what seemed to be just a few seconds, and realized that even if she did not make it that year, at least she had given it her best.
So on that one, you really can see the eye regressing back to E and then correcting the intrusion that she produced. Okay, so key questions. Why are English function words more intrusion prone? Are they not attended well? Can we tell this with the eye movements? If it's inattention, we should see that those targets are skipped more, gazed at less, and regressed to, monitored less. And then we have this earlier paper with Chinese English bilinguals that asked a similar question, but the paragraphs had tons of switches in them, and we wanted to repeat this with fewer switches and Spanish English bilinguals. And then excluding intrusion errors, just looking at when they read successfully, what evidence do we have of inhibition of English during the reading process? Maybe we would see something in reading aloud only, where they have to control which language comes out of their mouth. There's motivation for inhibitory control there, but maybe not in silent reading. Or maybe, if you believe some papers that are out, even in silent reading, we should find some evidence of the dominant language. Okay. So this study has 96 participants divided into 2 experiments. They either read aloud or read the paragraph silently. Each bilingual read 4 paragraphs in 4 different versions, single language, so once in English only, once in Spanish only, and then 2 mixed versions, one that's mostly in English with some Spanish and one that's mostly in Spanish with some English. In the silent reading task, they had comprehension questions they had to answer afterwards. 10 target words, meaning switch words, in each paragraph, in the mixed language paragraphs only. Okay. So these are the predictions. So if English function words are intrusion prone because of inattention, again, they should be skipped more, gaze at less, and there should be fewer regressions. In single language paragraphs, we should see normal language dominance effects, meaning English, which is the dominant language for these participants, being processed more efficiently, faster, more skipping. In mixed language dominance, maybe we should see reversal, maybe only in reading aloud. This just shows that these are just the number of data points we have in each of the conditions on the switch targets. And most of the time, they switch successfully. And then this is all the intrusions that we have. Most of them are in English function words by a lot. We do have some Spanish function words that produce intrusions and some English content words that elicit intrusions. Very few Spanish words that elicit intrusion errors, content words. The analyses I'm going to show you, we focused on full intrusions, meaning they never self-corrected, not after they produced it or not in midway, halfway through the word. And I'm going to first start out by showing you regressive eye movements to when they switched successfully versus they didn't on an English function versus content word. And then we'll look at just function words with comparing English and Spanish. We exclude this because we only had 3 data points. Okay. So it just shows you what the how regression rates look like in single language paragraphs, and you see that they're pretty low. These are in the mixed language paragraphs when they switch successfully versus when they make an intrusion error. And these are English function words, and you can see that gazing longer at those English function words helps you to produce them correctly. This is a significant interaction. But this means that there's increased attention to those English function words most of the time, not decreased attention. So those are more error prone, even though people are trying harder not to intrude. Okay, I'm just going to skip over that because we're really running out of time. This is just to show you that people who read aloud and did silent reading were very closely matched in their English and Spanish scores. And now we're going to be comparing across silent reading and reading aloud. So that's important. They're very well balanced. Any participants who didn't score at least 5 points higher in English on our naming test were replaced. And this is a paper with Mathieu Declerck reporting many experiments with no language switching cost in a variety of different comprehension tasks, semantic decision, lexical decision. They do get switch costs in reading aloud, but very little evidence for comprehension-based language switch costs. The bilingual interactive activation model, the revised version hypothesized no language nodes that would allow you even to inhibit if you wanted to in word recognition. Their older paper did have that. And then this is a paper of ours where we claim that you don't need inhibition when you're reading aloud. And this was with single words. And we show dominance reversing for picture naming, but not for single words. And then the single language paragraphs, so those comparisons, we're looking at these words, the woman, water, because, but, immersed in an English context versus the same words, the woman, water, because, but, with the same story told in Spanish, and that's what the comparison is. So it's the same targets, just what's different is the context. And now instead of skipping, I've flipped it around so that we can easily compare. So skipping is a sign of efficiency, right? So fixating is a sign of less efficiency in a way. And so I've flipped it so that we can compare this later to the gaze durations, kind of like when you look at reaction times and error rates instead of reaction times and accuracy, which are, I mean, you have to flip everything around. And then this is reading aloud, and this is silent reading, single versus mixed. And so we're going to look for costs, mixing costs, and then English, the dominant language shown in the darker lines. And basically the picture is very clear. English is showing a much bigger mixing cost, even in this fixation rate, which is supposed to measure a very early measure of lexical access. This is true for silent reading as it is for reading aloud, even though skipping rate is much lower in reading aloud. They're fixating more. We see normal language dominance effects in those single paragraphs, but a bigger cost for English with mixing. And now I'm just going to show you a bunch of measures. So this is fixation rate, gaze duration, regression rate, and there we see reversed language dominance in those mixed paragraphs, and total reading times. This interaction between language and the cost of mixing in reading aloud is robust for regressions and total reading times. In silent reading, that interaction is robust in every single eye tracking measure. Not what we were expecting. The only place where we see a bigger cost for English is here in the total reading times. And this is kind of what we were expecting to find more generally, that reading aloud would show evidence of inhibition more than silent reading. If anything, it's the reverse. Okay, so we're wrapping up here. I know I've gone longer than I should have. I'll try to do this quickly. So we have robust evidence for inhibition in picture naming times. Dominance reverses with repetition. We've seen this now in multiple studies, and Kalinka Timur just replicated with a different type of bilingual. In reading aloud, we see dominance reversed in intrusion errors, especially on function words and even on non-switch words, and despite increased monitoring, evidence for increased monitoring from the eye movement data. Even in silent reading, we're seeing the dominant language showing a greater cost, going from single to mixed in all eye movement measures. And dominance even reverses significantly in regressions and total reading times. And that was total reading times was the only place where we saw more control needed in this read aloud task for production than for silent reading. Otherwise, they look pretty similar. Here are two additional really good papers if you want to see some more evidence and arguments for use of inhibitory control over a dominant language in silent reading. And then I don't know why we were so surprised, because we have this fMRI study with also silent reading and showing evidence of more costs for switching to a function word that's in the dominant language. And so shouldn't have been so surprised. So closing thoughts, should we stop thinking about inhibition? No. Simple explanations can be right, even if some data patterns seem to be inconsistent, and even if it is possible to think of alternative explanations, and failure to observe significant correlations between different tasks that are supposed to measure the same thing can happen for lots of different reasons, and a failure to observe a correlation is not very strong evidence against something. Inhibition is the easiest way to explain this striking pattern of reversal. And even though inhibition is as debated as it is invoked, and people have claimed in most cases non-inhibitory mechanisms can accomplish the same goal, this doesn't mean that this is the right explanation. So only with activation, so the same way that inhibition only doesn't work, activation only also doesn't work. So if you could just activate your non-dominant language, why wouldn't you just do that all the time? And then it wouldn't be non-dominant, right? Like, why would you suddenly be able to do that in a mixed language context when you can't do it in a single language context? That is ad hoc and crazy. Okay, so I'm going to suggest if it looks like a duck and quacks like a duck and swims like a duck and parties like a duck, why not just call it a duck? Matt Goldrick and I have summarized our thoughts on this in a paper called Inhibitory Control of the Dominant Language, and reversal is just the tip of the iceberg, meaning sometimes what we see is a shrinking of dominance effects without reversal. And this is also evidence of inhibition, kind of the extreme of a continuum of effects found when the dominant language is inhibited. A meta-analysis that came out recently and questioned dominance reversal, and we go into this in detail in this paper if you're interested. We found that there were errors in almost a quarter of the papers that were summarized, and then fundamental flaws in the approach to analysis. Correcting for those errors, we find the vast majority of studies reveal reduced and reversed dominance effects in mixed language blocks. And in parallel in this paper, we reported that study with dense switching showing full reversal even in the read aloud paradigm. Open questions. Is inhibition domain general? We see parallel aging deficits across linguistic and non-linguistic switching, which invites a conclusion that it is domain general. On the other hand, we see failure to reverse dominance. We see that we do get reverse dominance in some tasks, and then Eunice Fernandez presented some data with Norwegian older English bilinguals, English bilinguals who did reverse dominance in picture naming. And so we are trying to figure out why those old bilinguals can versus ours can't in a picture naming task. Why does language dominance reverse at all? We've shown that it's not more efficient to reverse. What is most efficient is to get your naming times exactly the same. And then so this raises the question, why did they do that? And what are the experimental paradigms that make reversal more likely to be found? And then this need to replicate the reversal in the accent errors, I think, is open. And the final question, why do ERP studies and self-paced reading show a reversed asymmetry sometimes where the non-dominant language is showing a bigger cost? This is something we need to resolve in the field. Thank you very much for listening to so much yammering, and I'm happy to take questions.